jump in late here. But that bottom denominator tells you the derivative you're looking at to take the derivative of. AT. It's the same rules, it's just this tells you, hey, look at the t, don't look at the x. Now this is an easy one because there's only a t there. Things will get a little bit crazy if we stick different variables in there, multiple variables in there. We'll worry about that in a little bit. Again, the denominator of the derivative notation is important. It tells you what to take the derivative with respect to. And so, starting today, we'll probably use dy dx, dh dt, that kind of stuff more often than just f prime or y prime. Because f prime and y prime, they don't tell you what derivative you're taking it with respect to. Again, up till today, it's always been x, so it didn't really matter. You didn't have to worry about it. But today, we're going to have x's and r's and t's, and so we need to be careful and probably avoid the prime notation because it's not as helpful as the Leibniz notation. Alright, so number one's kind of a warm-up, so I feel like I should just pull a popsicle stick and ask somebody to find me that derivative. So, Rabia, 15x squared plus 7. Yes, no big deal. So here's what we'll do today. What if y squared plus y equals x? Can we still find dy dx? I mean, the answer is yes, but so how do I take the derivative of y squared plus y on one side and x on the other side? What do we... Well, the right-hand side's easy, right? The derivative of x is 1. But the derivative of y squared plus y, that's not just dy dx. There's more stuff going on there. And the stuff going on there is called implicit differentiation. And implicit, you'll see this in a minute, is a direct result of the chain rule. So if you got the chain rule down, then implicit is just, it just follows from the chain rule. All right, let's do some examples. Once you get the hang of it, it's not hard. The good news is there aren't any new rules, like sines and cosines and exponents and logs and powers, and product rule and quotient rule. All those rules are the same. We're not adding to that list during this unit at all, actually. In fact, we're not going to add to that list for a little bit. We're going to now use that list of things in kind of different ways. All right, find the slope of the line tangent to the graph. So that means derivative, dy dx, of y cubed equals 5x cubed in terms of x and y. Okay, so I need to take the derivative of both sides. We'll slow way down here and show the step that we don't normally show because we don't really need to. All right, taking the derivative of both sides fits all the other math rules that you can add 5 to both sides and divide both sides by 12 and square both sides. You can also take the derivative of both sides. Let's do the easy side first. Derivative of 5x cubed is 15x squared. Okay, easy peasy on that side. But the derivative of y cubed with respect to x, that's a little bit weird because it's x's and y's kind of mixed up in there. Any guesses on what the derivative of y cubed is? Because you're probably going to be mostly right. What's the derivative of y cubed? What would your guess be? 3y squared. And that's mostly right. 3y squared. But that's not x, that's a y, and so we need to chain rule that to take the derivative of y. So chain rule gives us a dy dx at the end. Okay, so we're sort of done with calculus. Now we need to do some algebra to solve for dy dx. dy dx equals 15x squared over 3y squared. That would be a safe stop. 5x squared over y squared. Okay, so it's the same derivative rule, but if you're taking a derivative of y, you've got to tag dy dx onto the end. That's not usually hard to remember, because if you forget to do it, and you end up with 3y squared equals 15x squared, and you know you're looking for dy dx, then hopefully you're like, wait a minute, I don't even have a dy dx. What happened there? So if you forget, like, and you don't have any, you sort of lost the point of doing the problem. So most people, it's not a problem of remembering to do it. It's still just using all the other rules. Number 2, find the instantaneous rate of change of y with respect to x. So dy dx. By the way, after grading the test, what is the average rate of change? You say slope, that's not wrong. Be a little more specific. Yeah, like Algebra 1 slope. I don't remember if it was this class, but it was definitely one of the other classes. I guess I hadn't said average rate of change in a while, because they did all sorts of stuff. Not average rate of change. All right, instantaneous rate of change. That's good old derivative stuff. So I want to take the derivative of everybody. So the derivative of y cubed with respect to x. I'll cheat and just put a big D over dx outside of everything there. So what's the derivative of y cubed with respect to x? 3y squared is part of the answer. Dy dx. And how about the derivative of y squared with respect to x? 2y dy dx. So anytime a y shows up, dy dx is going to show up. How about the derivative of negative 5y? Negative 5 dy dx. And then we're back to normal stuff. Minus 2x. And then a favorite place to mess up. What's the derivative of negative 4? 0. Okay, so I've done my calculus, but I want to find dy dx, so I need to do something to get like all of those together. Thoughts? Like, I want to solve for dy dx. How do I do that when there's 3 of them there? Let's factor them out. You could also view it as I'm going to add their coefficients. So I'm going to factor out the dy dx and then add their coefficients. 3y squared plus 2y minus 5. I'm also going to go ahead and move the 2x to the other side. And then I'm almost there. Divide by all of that stuff to get dy dx. Again, same rules as always, but if y shows up, when you take its derivative, dy dx will get tagged onto the end as part of the chain rule. Number 3, find dy dx of this thing. Okay, so the left-hand side has just got x in it. That's not bad. The right-hand side, what am I going to have to use on the right-hand side? If I have x times 1 plus sine of y. X times 1 plus sine of y. Be the product rule. So on the left-hand side, though, Tyler, what's the derivative of tangent of x?
Secant tangent of x.
That's the derivative of secant.
Oh, secant squared.
Secant squared, yes. So secant squared x on the left-hand side Uh-oh, my wife's calling, and she called twice, so that means on the other side we have to do the product rule. I'm going to try to do it. Do you want me to do it in place, or do I need to write it out? I'm going to write it out because this is new stuff today. So f is equal to x, g is equal to 1 plus y, 1 plus sine of y. Again, if you get, usually I don't write it out, but if it's a little bit tricky, I'm doing something new, maybe it's worth it to slow things down a little bit. Mia, well, sometimes you get the easy one here. What's the derivative of x? 1. Ian, you kind of got on the spot here. Derivative of 1 is 0. What's the derivative of sine of y?
I want to say it's cosine y times dy dx.
That's it. That's it exactly. Derivative of sine is cosine, and then the derivative of the inside, think chain rule. Derivative of sine is cosine. Derivative of y is dy dx. Well done. Now we're ready to put it all together. So first times derivative of the second, x cosine y dy dx, plus the other way around, 1 times that would just be 1 plus sine of y. And now I've got an algebra problem. Like, I still need to, I'm not done. This is not a safe stop because I have to solve for dy dx. So, I mean, I'm almost done, but I'm not done yet until I solve for dy dx. So, let's see here. I'll need to move the 1 and sine of y over. Secant squared x minus 1 minus sine of y. And then, if I'm thinking ahead, skipping steps, after I move that stuff over, what would I do next to get dy dx by itself? I would divide by this stuff. I'll show it. So divide by x cosine y. So that's a wacky and weird answer. But I guess that's what we should expect when there's tangents and sines and products and chain rules and all sorts of things going on. That's also a good reminder to make sure you always include the argument with sine. Sometimes, and I'm guilty of it as well, sometimes when we're working with sine and cosine we drop the argument just because we're lazy and we throw it back in later and it's no big deal. But be careful, especially on a problem like this, because we got x's and y's, so make sure it's clear what you're taking the sine of or the tangent of or the secant of. Number 4, find dy dx. Most of this looks straightforward. What about this term? What's this going to be? What's that going to take? What's that going to require? What rule? Product rule, 4x times y squared. So derivative of 3y cubed, that'd be 9y squared dy dx. Again, anytime y shows up, dy dx is going to be come shortly thereafter. Alright, product rule. I'm going to try this one kind of on the fly without writing everything out. So first times derivative of the second, 4x times, Leo, what's the derivative of y squared?
2y.
Yes, thank you. 2y dy dx. Plus the other way around, the second is y squared, but not dy dx because it's just the second, not the derivative of the second, so just the second, y squared, times the derivative of the first, which is just 4. And then we're back to kind of normal derivatives here. 8x cubed equals 9 plus, Joe, what's the derivative of 11y? 11 dy dx. Calculus is over. Now we get to worry about algebra. Kind of a pain. I need my dy dx terms on one side and my not dy dx terms on the other side. So let's see if I can do this all at once. So on the left hand side I'll have dy dx times 4x2, which I should just make 8xy, but whatever, minus 11. So I moved it over and factored it out. And then all the other terms are going to the other side, so 9 minus 9, uh-oh, I forgot something, didn't I? I need another 9y on there, or 9y squared. It's okay, fix it. Wasn't careful enough. So now moving to the other side is this guy and this guy. So 9 minus 4y squared minus 8x cubed. So dy dx. I'm going to now divide by all of those things. This is just algebra record keeping stuff. I'll go ahead and multiply 4 and 2 and get 8xy minus 11 plus 9y squared. Anytime y shows up, y prime is going to show up. But all the other rules are the same. So I was very encouraged by that last test. If you did well on that last test, this isn't too much more to add on to that. Now, if you didn't do well on that last test, meaning you don't know all the rules we're supposed to know yet, then the snowball continues to build. Number 5. Find the slope of the line tangent to the graph of this thing. Again, we just keep using all these different Spider-Man meme, like it's all the same. Find the derivative at -1, -1. So this will be kind of the same thing we've been doing, but we'll just plug in -1, -1 somewhere at the end. Okay, derivative of x plus y cubed. I guess I have an option here. The option I rather not take is to cube this thing out. No, thank you. The option I am going to take is to just use the power rule on that thing as a whole. Okay, so how would I use the power rule? If I have something cubed, bring down the 3, decrease the power by 1. But then chain rule, I got to multiply by the derivative of the inside of that thing. So what's the derivative? Lauren, I'll give you both of them. What's the derivative of x plus y? The derivative of x is 1. What's the derivative of y? dy over dx. Good. So 1 plus dy dx. So already the algebra is going to be kind of ugly on the left-hand side. On the right-hand side, look at this. I get to pull all kinds of popsicle sticks today. Looking around, no Grenier. Anders is here. Kylie's here. So Brandon, how about the derivative of, these are just going in order on the right-hand side. Brandon, how about the derivative of x cubed? Lauren, did you just slip him the answer for this one, or are you handing him something else? No? Brandon, what's the derivative of x cubed? Brandon, you with us? Do you know it? Okay. Okay, now she's trying to slip you the answer. Somebody help him out. What's the derivative of x cubed? 3x squared. Anders, how about the derivative of y cubed?
3y squared dy dx.
Very nice. 3y squared dy dx. And Kylie, the derivative of -6? 0. It's the easy one, but you got to know it, so 0. Okay, so we've got dy dx. at this point, we kind of have a choice, and I feel like math teachers usually pick one way, and math students usually pick the other way. The choice is, I can do some algebra and solve for dy dx. That's what math teachers usually do. Or I can just go ahead and plug in -1 for x and -1 for y and just sort of see what happens. I feel like that's what math students usually do. And I think you're right. Like math teachers, we're too eager to do the math when we could take the easy way out. Let's plug in -1, -1, and maybe some of this stuff goes away and it gets easier for us. So again, you can do algebra first or you can plug in first. Either way, you're going to have to do both. So 3 times -2 squared, 1 plus. Now, if you want to switch to y prime, that's okay because we've only got one derivative. They're all dy dx's. It's clear now. So if you want to take the easier notation, that's okay. So I'm going to switch to y prime. Again, that's a little bit dangerous because we're not always going to have y's and x's. 3 times -1 squared is 1, plus 3 times -1 squared is 1. Oops, I'm switching to y prime. Yeah, I'm going to say if you switch them both, otherwise you're going to get confused. Like why does my equation have a y prime and a dy dx in there? Okay, so 3 times 4 is 12, distribute to 12. 12 plus 12y prime equals 3 plus 3y prime. Okay, well that's not too bad. Subtract the 3y prime over and get 9y prime. Subtract the 12 over and get -9. So y prime is -9. No, not -9. No wonder you're saying, -1. All the same rules as always. It's just if a y shows up, then dy dx has to show up. All right, then we get into some trickier ones. Number 6. X squared minus y squared equals 36. Find the second derivative in terms of x and y. Find the second derivative in terms of x and y. Okay, well, big picture, this is kind of the same. Like, take a first derivative, get it cleaned up, take a second derivative. So, first derivative, I got 3 terms I need to take the derivative of. We're going to get through almost everybody today on the popsicle sticks. My red Hulk Hogan feathers are still infecting everything up here. So in order, Kira, what's the derivative of x squared? 2x. Good. Stop there. By the way, if you do say dx dx, that's okay, because what is dx dx going to be? 1. So if you were just sort of going overboard with taking derivatives, dx dx, we don't usually write that, but it wouldn't be wrong because it would just be 1. Alan, how about the derivative of y squared? Good, 2y dy dx. And Jace, the derivative of 36? 0. All right, well, let's find. I need a second derivative. And you could do it here, but let's find dy dx first, and then take the second derivative off of that. So I'm going to move the 2x over. -2x, and then I'll divide by -2y and get dy dx equals x over y. Okay, well that's not too bad. So there's my first derivative. My second derivative then, so I want to take a derivative of dy dx and a derivative of x over y. So on the left-hand side, I just want the second derivative. That's where I'm headed. On the right-hand side, How do I take a derivative of x divided by y? Quotient rule. So quotient rule, gf prime minus fg prime over g squared, where f is the top and g is the bottom. So these seem simple enough. I'm not going to write out f prime and g prime. Did write out the formula though. So gf prime would be y times the derivative of x, would just be 1, minus f times the derivative of g. What's the derivative of y? dy dx. Over the bottom squared, y squared. Okay, so let's clean that up a little bit, which I guess is just multiplying by the 1. Y minus x dy dx over y squared. That's not wrong, but my directions say in terms of x and y. That means I don't want dy dx as part of my answer. So I'm not wrong, but I'm not given what they ask for.
Can you put x over y in there?
Yes, that is the trick is, well, wait a minute, I know what dy dx is. It's over here. So in place of dy dx, which isn't supposed to be there, I can put x over y. So y minus x times x over y all over y squared. All right, that would be a safe stop answer. Move my face out of the way here. Right, because that's a second derivative. If only x's and y's in there, we're good. That is a safe stop answer. But multiple choice, of course, is going to mess some things up. Let's see. I don't like that y in the bottom. So I'm going to multiply top and bottom by y to clear out that denominator. This would be a great spot to get partial credit on a multiple choice test. So I've got y squared minus x squared in the top, and then y cubed in the bottom. Okay, that's a little cleaner looking than this. It certainly still answers the question. That's a safe stop. But a multiple choice test is going to go one more, and they really like asking this question, so you'll see it again. Y squared minus x squared. Look back at my original problem. Y squared minus x squared. That looks familiar. Sort of. We know that x squared minus y squared is 36. So what does y squared minus x squared equal? Negative 36. So I could write this as negative 36 over y cubed. And that would be the multiple choice answer. So that one we always show because there's some algebra gymnastics there at the end. We're like, what are we doing here? But you got to be able to do it to make it match the multiple choice answer. All right, let's just power through. We got 2 left, and then we won't have any notes on Monday. All we'll do is answer some questions and work some more together. A spherical balloon is being inflated. Write an expression for the instantaneous rate of change of the volume with respect to time. That's a mouthful for dv dt. The formula for the volume of a sphere is 4/3 pi r cubed. Okay, this is going to be a little bit weird. We haven't done one quite like this. If I want dv dt to show up, what do I need to take a derivative with respect to? dt, time. So what's the derivative of v with respect to t? That's the easy side. That's just dv dt. How about the derivative of r cubed? 3r squared, so 4/3 pi 3r squared, but I'm not taking the derivative of r with respect to r, because that would just be dr, that'd be 1. I'm taking it with respect to time, so I need a dr dt. And so this is a great example of where the prime notation doesn't work. I can't use v prime and r prime because I've got all these different variables. So dv dt, some of this cleans up a little bit. 4 pi r squared dr dt. Because it's not dx anymore, it's dt. But it's still the same rules, it's just now there's a t in the bottom instead of an x. Last one. Water is draining out of an inverted cone. So, right, something like that. You got water dripping out of a cone. Write an expression for the rate of change of the volume of the water with respect to time. So again, it wants dv dt. And our formula is 1/3 pi r squared h. So d dt of all of that stuff. Left hand side, easy, dv dt. The right hand side, I'm going to view as a product rule problem, because I got two variables in there multiplied together, so it's a product rule problem. So let's see, first times derivative of the second. So 1/3 pi r squared, that's the first. Times, what's the derivative of h with respect to t? I sort of just gave the answer. What's the derivative of h with respect to t? Right, so what do I write? What do I write that as? dh dt. Because that's the derivative of h with respect to t. Plus the other way around, so h times the derivative of this part, so 1/3 pi. What's the derivative of r squared with respect to t? So 2r dr dt. So that we go a little crazy with our variables there. We got v, r, h, and t. Yeah, 4 variables in that problem. We'll work a problem like that later next week. That'll be like Tuesday, maybe even Wednesday, where we'll give you information about how the water is dripping out and how long will it take and all this. But right now we just need to worry about finding derivatives. That's fine as a safe stop. I don't know that there's a whole lot you could clean up from there if you wanted to. Factor out a third and a pi maybe and an r, but alright, today's assignment is worksheet 1, 1 through 10. Like, worksheet 1 has 19 problems, so just a heads up, get carried away if you want to, but Monday's assignment will be 11 through 19.